Hello again. This is basically part 2 of our point slope, using point slope form lesson. And remember, point slope is y minus y sub 1 equals m times the quantity x minus x sub 1. And I got 2 more examples here. And these are examples that you typically see either in a first-year algebra class or even in a college algebra class, because they still do these types of problems, and students still struggle with them. I mean, when they first do them, they struggle. It goes to show that they're probably still going to struggle. And it's because we don't really focus on point slope form that much. We do it for maybe 3-4 days, and that's it. And you never really see it after that. And I mean, if I hadn't seen something in 2-3 months and then somebody told me to do it again, I would have a little bit of difficulty learning it too. So students never really have the time to adjust and grasp it. So maybe if it's online, you get to see it and you get to use it to your heart's content. So I got 2 more examples. The last example we did was a little difficult, but it's pretty good to have that kind of practice. Now what we're going to do is we're going to look at a graph, and we're going to figure out what it is in slope-intercept form, and then we're going to use this nasty little function notation right here, which usually just intimidates students to just stop, but I promise you, if you keep up with it, you'll be able to do these types of problems too. But let's start with the graph first, because that's more commonplace. So I'm looking at this graph. It's got a positive slope, and its domain goes on forever. It goes on forever to the left and to the right, and its range goes on forever too. You know, it keeps going down and it keeps going up. So we're not going to talk about its domain and range. It's negative infinity to infinity for domain, negative infinity to infinity for range. Nothing's changed. But I'm looking at this graph, and it's got a positive slope, and it goes through the points -3, -1, and 2, 1. And what I'm telling you is, I want you to use point slope form in order to figure out what it is in slope-intercept form. And slope-intercept form is y equals mx plus b. And that's how I usually want you to write your equations. And sometimes you'll have an example in the book or on a test that says put it in point slope form. And students, even when I do that and students end up putting in slope-intercept form, I don't take off any points, because that's ultimately what I want my students to do anyways. In fact, I don't really know any teachers that do that, but I could be wrong there. There might be a few that do. With that said, what I want to do is figure out how to put it in y minus y sub 1 equals m times x sub 1 form. Well, here we go. If you want to do it, the first thing you got to do is write out the formula. Now for y sub 1 and x sub 1, you could actually use either this one for x1 and y1, or you can use this one for x1 and y1. But since you see this point first, we're going to use this one for x1 and y1. And we're going to call this x2 and y2. This is going to be my first x and first y that you see, second x, second y that you see. Well, okay, when I'm using point slope form, the y is left alone, and I subtract y sub 1. But what's my y sub 1? It's -1. Equals my slope. Now some of you are saying, well, you didn't use that formula you did in that previous example. I know, because I'm lazy. Well, that's not actually true, because I want to show you how to find the slope looking at a graph without having to take the 2 points, because that's actually a waste of time. If you want to find the slope, count the rise over the run from one point to the other. So what I'm going to do is count how much it goes up and then to the right to get to, from this point to this point. So I got to count up 1, 2 over 1, 1, 2, 3, 4, 5. So y minus -1 equals 2/5 x minus -3. Let's simplify this a little bit. 2 negatives in a row make a positive, equals 2/5 x, 2 negatives in a row make a positive. Now some of you would have just skipped that step and made it a positive right away, and that's perfectly fine. 2/5 times x is 2/5 x. 2/5 times 3 is 2 times 3, which is 6, over 5 times 1, which is 5. Almost done. We've got to get y by itself. Subtract 1 on both sides of the equation, so you subtract it on this side, and you subtract it with its like term on this side. y equals 2x over 5, or 2/5 x, plus, now a lot of students have a little bit of difficulty figuring out what this is. What's 6/5 minus 1? Okay. I want to turn negative 1 over 1 into a fraction with a denominator of 5 so I can subtract these properly. Well, what do I have to multiply on both the numerator and denominator to do that? 5. So negative 1 is the same thing as negative 5 over 5. That's probably taking the long way to do it. Some of you are going to figure that out, but it's good to show it anyways. Y equals 2/5 x plus a fifth. And that's your answer. Y equals 2/5 x plus a fifth. Moving along. I got this last problem, this function notation problem. It's basically a graph. Well, it is a linear equation. It's a graph, but it's showing it to you in a different form and saying, okay, solve me if you can. Well, we're going to solve you. If you paid attention to my lesson on functional notation, you'll find that it's really not that intimidating. Basically, what functional notation means is this: that f of x equals something. And what that something is, it depends on the equation. And I said whenever you see f of x, it just means y. They're basically one and the same. Now, what you substitute into this value is the actual x, and what it's equal to is the y. Let me say that again. What you substitute into this parentheses, inside this parentheses, is the x value, and whatever it's equal to is the y. So, when x is 4, y is 9. When x is negative 4, y is negative 7. That's really all there is to it. Now I'm going to go ahead and erase that. Well, not all of it, but at least this part, so I can have some room to do what I'm supposed to do. And I'll write it again. When x is 4, y is 9. When x is negative 4, y is negative 7. And then you just put down your x1, y1, x2, y2. So what we're going to do is we're going to figure out our slope. Oops. Which is the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We're going to go ahead and do that very quickly. And that comes out to negative 16 over negative 8, and that's just 2. Okay, so far so good. We know that our slope is 2. And we're going to substitute that into our y minus y sub 1 equals m times x, quantity x minus x sub 1 formula. Fortunately, this one's not brutal because my slope is just a positive integer. So when I'm multiplying it in, whoo, it's going to be nice. It's about time. Y subtract 9 equals my slope, which is 2, x subtract 4. 2 times x, 2 times negative 4. It's negative 8. Add 9 to both sides. Y equals 2x plus 1. That means when I graph it, My y-intercept is 1, my slope is 2 over 1. It's fantastic. It goes on forever in the x values, which means its domain goes on. Its domain for the y value, its range for the y value go on forever as well. But that's basically a quick introduction into point-slope form. 4 different types of examples you'd see, for the most part. And given that piece of information, you can figure it out relatively easily. I mean, other than that, the only other example I can think of off the top of my head, and I'll show it as a precursor, but I'm not going to go ahead and do the problem, is this. You might get a problem that says, well, m equals 2, and it passes at the point 3, negative 1. Well, in that case, well, I'm going to go ahead and show it anyways. You do y minus negative 1 equals 2, x minus 3, solve it. You get y equals 2x minus 7. That would be the most typical type of point-slope problem you find. But like I said, for the most part, point-slope form, it's not necessarily the easiest way to do it, but if you know how to do it, then you can do it for most of the problems that you do. And that's actually what students are looking for. They're looking for consistency. Best advice I ever got from a student, actually, very interesting, the person was struggling in math. They ended up doing well in my class too, which was nice. When I gave out suggestions one time, they said, just teach it one way and that's it. I don't care if it's easy or difficult, just teach the way that you think is good, and just make sure you teach it that one way, because I'm already confused in math anyways. And that's what I usually try to follow that advice, and it has worked for the most part for teaching math. Anyways, with that said, that's a 2-part lesson into point-slope form. And you can always catalog it and use it, because it will come back and it will reoccur. It's just that a lot of times they don't emphasize it in books or tests or quizzes. You see it once in a while and then it goes away, and then people just expect you to remember it once they tell you to remember it again. So with that in mind, keep that cataloged and have a great day. Goodbye.